Okay, minimize and start right here. Okay, legally emergency system, legally required standby system, and optional standby system. These are very, very important three systems, guys, that you're going to encounter in every building. And all of us, we know what the emergency system, because you guys, the bug guys that we put in the building, that's emergency system. We'll talk a little bit about legally required standby system. Optional system is up to you. You have a generator to back up Dunwoody. All the loads are Dunwoody, light and receptacles and HVAC equipment. That's your optional standby system. So we'll talk a few things, guys, about details about them and where you find them in the NDC code book. Understand what are they and what the difference between them is a big deal. That's what we're going to be doing. Size generators for emergency. I'm not going to talk too much about generators. You guys are expert in sizing generators with the software right now. We have, I walked you through the software, and my friend Jerry Buggs also walked you through the softwares. Really nothing to it other than sizing in two ways. Number one, running load and starting load. We size based on running load and starting load. So that's what we're going to be talking, guys, about. How connect typical emergency standby system. We'll talk about them. Understand the transfer switches for emergency system. Here's the sign. If you guys are sleeping, here's where I want you to wake up. In the NEC code book, I've never seen a slide better than this. In the NEC code book, there are 5 systems that I know of. These are the 5 systems that I know of that emergency or legally required or standby is a big issue. Take this. If you go to chapter Article 700, it will tell you anything you need to know about emergency system. Emergency system. It doesn't tell you where you need the emergency system, guys, but it tells you if you have an emergency system, here's how you have to wire it. All that you need is an emergency system. There's a slide that I want to show you, one of the most important slides that tells you the difference between all these 4 systems. Okay, Ashley emergency system is basically the emergency light that safely make the people exit the building with some elevators, if it's a riser, and so forth. Any question, guys, about the emergency system? That's the article that talks about it. And these are in terms of importance. The second article is legally required standby system. After we get the people out of the building, and the government, the authority having jurisdiction, aka local, state, or federal government, can decide that certain loads, we need more than just light. We need a couple of receptacles in 911 operating system to be running, right? We don't want the people to exit if we lost power. Police stations, for example, there's certain loads need to be up and running, not just emergency loads, right? If you lose the system. All these systems can be legally, it's called legally required standby system. In terms of importance, the most important one is what? The emergency system. People's life depend on it. The second one is legally required standby system. These people's life depend on it to a degree, less than emergency system. Okay, the second, so this is the most important system, number 1. Second most important system, number 2. I'm going to move into the, actually, in terms of importance, I'm going to move into the healthcare. Healthcare facilities, guys, Article 700, 517. If you go to the healthcare, it will tell you certain receptacles and certain lights and certain systems have to be connected to so-called essential system, which is critical and emergency system. So these are, we're in a hospital, you're on a table, your chest is open, and they're operating on you. Do you really want them, when you lose the power, to have an exit light and they just exit the room and leave your chest open, right? You would hope not. So what do, guys? They have a backup for all emergency operating rooms, backup for patient rooms, receptacles, and lights. So if you are being operated on, you will have enough power. They will have enough power to finish that operation and continuously working on you. So that's the third important system, or the second. This is my second important system. The third important system is called 708. This is my third important system, second and third, right, in terms of importance. Second and third. Legally critical operation power system. This, believe it or not, Tau came after Katrina. Remember, guys, Katrina and September 11? If you were younger in September 11. After September 11 and Katrina, the federal and the state government decided there are certain buildings so important for the survivability of the nation, the food chain, security, transportation, military, all these good stuff. They decided that certain buildings must be completely backed up with power. A good example of this, federal banks, police stations, and so forth. So these are another system. If we are to lose power, we need to have a backup power to run all these receptacles, HVAC equipments, and lights. Can I get you guys to understand? This one came as a result, as a matter of fact, of 9/11 and Katrina. Okay, so that's the third important. The fourth important is standby system. Standby system, optional standby system, done with it. This room, if we lose power right now, all what I need right now is just an exit sign to get us out of this building safe, right? Now, if we decided we are so important and we really need to continue, you guys like to listen to Chad all the time, we're going to continue the lecture. So we're going to have a backup generator to come up this bead, energize, and switch you into that generator. That's called the optional standby system. No reason for it other than the continuity of the business, because we decided our business is good. We're not government, we're a private entity, and we decided our business continuity is important, so we need to back up. That's called optional standby system. Any questions about these four systems? Again, the most important system, the emergency system. Here's the funny thing is, if you go to the critical operation area, like a federal bank, inside it, you're going to have, inside that system, you're going to have an emergency system, a legally required standby system, and critical operation system, all in one building. And maybe also optional standby system. If you go to a hospital, the same thing. You're going to have an emergency system, legally required standby system in the hospital. That goes by the term of importance. Can I get you guys to understand these four articles? Okay, so that's basically the major thing about emergency system, legally required, and optional standby system. We're not doing hospital today or critical operation. We're going to focus on these, the first three, 700, 701, and 702. You guys have done with me, we have done a standby system, as a matter of fact. Our building had an auto transfer switch that would come. We didn't depend on it as an emergency system. We call it standby system. And you're going to see the difference between all of them. There's actually a major difference here. Really, the major difference is emergency system have to come up within 10 seconds. Legally required standby system have to come up within 10 seconds. Optional standby system whenever. And critical operation system have to come up, I believe, within close to 60 seconds. I have to check on that one. So that's really the major difference. If you want a system to come up within 10 seconds, it's emergency system. Within 60 seconds, legally required. Whenever, it's optional. And within 60 seconds, also critical operation system. Any questions guys about these four systems? Very, very important. By the way, this PowerPoint presentation will have a copy of it, guys. So, this is chapter 16. Chapter 16. Okay. They call it COPS here, Critical Operation Power System. Okay, moving on to a couple of things. I know you guys are engineers and designers. A couple of things that you need to understand when it comes to emergency systems, all these systems. There's a lot of articles, guys. For example, NFPA 90 talk about standard for healthcare facilities. That's what tells you which system needs to be an emergency system. Life safety code, building life safety code 101. I have a copy of it if anybody interested. That will tell you where do you need exit signs and where do you need egress light. Because the code doesn't tell you where do you need the egress signs and the exit signs and egress light. It tells you if you need them, this is how you wear them. These, the same thing in the healthcare facilities, guys. If you need them, this is how you wire them. So these are more different articles that talks about it. NFPA 110 standard for emergency and standby power system, how it works and how it's put together and so forth. If that's not enough for you, there's ANSI and IEEE. Recommended practice for emergency and standby system in an industrial and commercial building. It goes to how to test them. It's not enough to put a generator sitting there. When you call up on that generator to come up, it's not going to come up because the battery is dead. So they have a procedures how to test these equipments. Anyway, if you want to go to the next level, Dustin, when you work for your engineering firm, these are documents must have. I have a few of them. If anybody's interested in my basement, as a matter of fact. It goes deeper into how to test and assign areas as emergency areas, test them and operate them and so forth. Any comments, any questions? Okay, so that's just FYI information. Um, Unit, bug guys. You can get the emergency system, guys. Emergency system, if you have an emergency system, legally required standby system, or the critical operation power system, or the optional, they need a second source of power. Always, you have one source of power is the utility. The second source of power could be a generator, could be a battery, could be a wind turbine, could be a solar system. So you need another source of power for all these four systems. That's why they call them emergency systems and it's special systems, right? So for these, you can have they call it the self-contained battery power units. A big fat name for bug guys. Remember that bug guys that we did? These guys, convenient, efficient, you can put them, need for emergency, so you put them for emergency power, confined to a definite area such as stairways, power demand in these areas is low. So these are the areas where you can put self-contained bug guys. And what we do with these, as you guys remember, when we have a bug guys like this, what we do is we connect it and I have another light in this area, and I have my switch, right? Remember how we switched them and we brought the neutral to them, and that what we did, we went from the line side and we fit the fixture. Can you see how we did it? Here's a fixture, normal. This is normal fixture. This is emergency fixture. So from the line side to the bug eye, we fit that one. So if I sense that there's no power in this area, there's a little relay here that actually connect to a battery. There's a battery here, and that relay is tying the lights to the battery to the system. It senses there is no juice coming out of the system, and it switch you into a tiny little battery that gets you for I can't remember, 80 some minutes, 90 minutes, something like this. It gives you enough ample amount of light to get you out of the room. Any question, guys, about this? This is the cheapest, easiest way of having an emergency system. Cheapest, easiest way of having an emergency system. Okay. Building may require legally required standby system. Now, who classify every building every commercial industrial building that open to the public need an emergency system? Then who qualify it, guys? That's by the building code 101 safety code. But which one needs a standby system and which one needs legally required? Legally required is usually by a government, a state, federal, or local government decided certain loads need to be legally required. Wiring and performance require different types. We'll talk about the types. Wiring for emergency system. You guys know this one. If you go to this article, it tells you if you're wiring for emergency system, you must keep all the branch circuits and the feeders and the switches and everything completely separated from any other system. Completely separated. Can I use a conduit that has an emergency circuit and a normal circuit in the same conduit? No. So that's where it tells you independent of all wiring systems, not enter the same raceway boxes or cabinets, so complete independent system if you have an emergency system. Any question, guys, about this? Emergency system.
The bug guys need to be separately wired?
The bug guys, the circuit, the bug guys, let's go back to the bug guys. The bug guys, see the bug guys, the only circuit conduit is right here. That conduit has to be separate. But where it ties to the system, you have to enter here somewhere, the box, to get the juice. But from here on to this area have to be separate. So the bug guys kind of because really the bug guys, the emergency light is right in here. That's where the emergency light, right here, inside. This is where if it's a standalone system, where the emergency light. Let me draw this one, because Chad likes to draw. Here's an emergency light, and here's a normal light, and here's an auto transfer switch coming power in, and I want the power to go to the emergency from here, my gen, and from right in here, I want to take the power and go to the lighting circuit. Cool? So that's where this circuit here has to be, this This system here is my emergency system. Have to be completely independent of the normal system. This guy here, all the way, is my normal system. Normal. So, long story short, Chris, I can't put this circuit here and this circuit in the same contact. These two circuits. Separation of circuits.
Emergency wiring is normally class 2, right? So
No, Ch. It could be, but it could be Ch. Most of the time it's Ch. Like the wire the same, the conduit the same. The only thing is they don't want you to put them in the same conduit because you compromise the integrity of the emergency system. Yes, Rob?
do you have your emergency lighting like fixture and location? Do you have a secret conduit as well then?
If you have an emergency,
So like you have one lamp in that light, you have to use separate conduit for that.
yes, coming to, so you will have two branch circuits coming to that fixture. Two branch circuit. I show you, there's an example, nice example there. Okay, so legally required standby system, separate service permit for emergency and legally required standby system. You need to, now this does not meet the emergency code though. You need two sources of power. They allow you guys, for hospitals commonly, they allow you to have regular power and emergency power. So basically two utilities coming to your building. This does not meet the safety code though. But the NEC code allows you to have two sources of power as one emergency, one normal, instead of having what? One generator, one power, one source of power. So good for legally required standby system and emergency system, question mark here though. A lot of building codes, they don't allow you to do that because if there's a storm and it will knock down the power here, what's the chance that the storm is going to take the second line there? Unless you really prove that these lines are completely different, like in downtown Minneapolis, there's a network. You can bring, it's highly unlikely you could bring the network down, really hard. So you bring two feeders to your building from that network, maybe that will qualify. In the middle of nowhere, a storm will come to your building and it's going to knock down the two. You think if you put them a mile away or say 2 miles away from each other, a storm usually cover that. You know, a storm comes, will knock down the power. Most likely it's going to be within that 2 miles and will get you down. So again, this is good for emergency, question mark for good for legally required, question mark for emergency. Okay, now that's basically it, the emergency separation, and needs 10 seconds. Wiring in the legally required standby system now, Chris, if this fixture is legally required standby fixture, I can bring the emergency circuit and the legally required standby circuit and the normal circuit in the same conduit. That's a major difference. They can occupy the same conduit, legally required standby system. So it's not expensive. So if I have a lighting fixture over here, and my lighting fixture has two feeders, here's one feeder emergency and one feeder normal, right? Here's emergency and here's the normal. These are coming from two different panels. Here's my legally required panel, and this is my emergency panel. I'm sorry, this is my normal panel. I can put these actually in a conduit, in the same conduit, and they're coming to the same light, or they're coming to something else. This is my light. So like you just said, I have one bulb, two bulbs, three bulbs. One bulb of them is actually legally required standby system, and the second two bulbs are normal bulbs. I can put them in the same conduit. That's a major difference in legally required versus emergency. Another major, guys, they allow you the second source of power to be ahead of the disconnect service for legally required, not standby system. Here you go. They allow you to come. Can you guys see this is the main panel? This is my 4,000 amp switch gear, right? I can come ahead of the switch gear. Can you guys see where they came from here? And I feed my legally required standby, legally required panel. Legally required panel that's going to feed legally required systems. I can feed it from the line side. A good example of this, guys, is fire pump. A good example of this is a fire pump. You can sneak from here and feed your fire pump. Not commonly used, except for fire pumps, not commonly used. Who cares? In a case like this, guys, it allows you, you don't have a generator, you don't need a generator. Remember, it's legally required. It's not standby. It's not an emergency system. Any comments, any questions about that? Okay. Generators must be used to supply emergency. You have to have a generator for emergency or a second source of power. Fuel, so we have another source of power, most likely for emergency is the generator. You need the fuel. It's not enough to have a big fat generator. Most of the time, guys, you have 24, they have a 12, 24, or 48 gallons of tank for the generator. Remember what Jerry was saying? 24 to 48 gallons is a good example for emergency generator to have for driving the engine. Otherwise, you have a generator that doesn't fuel for it. So what's going to do for you? Okay, regulations affects the selection of the fuel. I'm going to refer you to Jerry Bob's presentation, awesome presentation about the EPA requirement. It's on YouTube. EPA requirement of generators. Right now, guys, it's almost like Jerry said, unless your generator is an emergency generator or legally required standby generator or CUP generator, these are all emergency under the umbrella of required generators for hospitals, CUP system, emergency, or legally required. Unless it's one of these, a standby, if it's a standby generator just because you want to, it's going to cost you twice to meet the regulations of EPA regulations right now because of the tier 4, tier 3, and tier 4 that they're requiring. Emission reduction and all this good stuff. Really nice. I'm going to refer you, I'm not going to talk too much, I'm going to refer you about regulations, EPA regulations, guys, to the presentation that Jerry did. Unreal. So just remember one thing, if somebody say I want a generator, ask them, is it an emergency generator, legally required, or CUPS, critical operation power system, or hospitals? Is it one of these? Yep, then we're safe. If it's standby generator because we decide to, we want to just run continuous low diesel, you better consult EPA requirement. You can do it, Chris. I don't know if you saw the presentation, but it's going to double the price. It's going to double the price of your generator. If your gen is 1 million, it's almost going to make it $2 million to install that generator because of, remember how we talked about reducing the emission, the NOx, and all this good stuff. So be aware of that one. Generator, you need some type for generators, guys. We need to cool the generators. So you can either liquid cool them or air cool them. Most of them, guys, are air cooled. The air cooled. Most of the generators that we use for emergency system are air cooled. You need to have the generator, as we say, if you have a gen, you need the same voltage. The last thing you want to do is to have a generator running at 480 and your system is 208. OCHA can solve the problem for you. How do you solve the problem for me? Put the transformer. That's what we call a bad design. To put a generator 480, step it down to 208 to feed a building that's 208. A smarter engineer or designer would design immediately at 208. Any question, guys? Any question about these? Cooling system for the generator and so forth. Capacity. When we size the generator, guys, we talked about two things. Starting capability, starting KVA of the generator for motors, determine the correct size for the system starting, and determine lock rotor current for amps. So starting and running. So we have running load and starting load for the system. And we have the common software, and every time you guys put a horsepower, it multiplies it by almost 5 to 10 times the KVA rating of that horsepower to get you the locked rotor current. They call it locked rotor KVA volt amps of the motor. So when you have a generator, as we guys size, you have to have for emergency, legally required, or any of these systems, two things in your mind. How much KVA do I need to run? That's this amount. And then how much KVA I need to start at one step. That's this much. Based on these two criteria, you can get a certain size generator. If you guys remember the software that we have, go change, put all the stuff that we did, we put them in one step. we came up with this size generator. If we actually put them in different steps, meaning we're going to start them at different times, 10 seconds, 10 seconds, 10 seconds, 10 seconds, stagger them, then your generator from this size, you come up with the little size. I always compare it, guys, to trying to, like, if I want to push all of you together, that's a start. Now, if one at a time, it would be easier to take Nick and push him, now he's running. Take Chris, push him, he's running. Take Dustin, push him, he's running. It's easier to push one at a time than everybody standing there and you're trying to push all these loads from a standstill. Does that make sense? Very important, the starting capability. A good engineer would always stagger the load, meaning you start this chunk with an auto transfer switch, another chunk with another auto transfer switch. What's the problem with this? Spindy. You have to have different auto transfer switches to start them at different stages. Okay, so that's basically sizing the generator. Commercial building must supply continuous KVA and locked rotor. So when we size again, I can't emphasize the continuous KVA, that's my running, and the locked KVA, locked rotor KVA, especially for motors, especially for machines. Because to start a machine, guys, is not like to start a lighting fixture. The starting current on a motor is 6 to 10 times more than the starting current on lights and so forth. When you have an emergency generator, guys, you have something called derangement signals. Derangement signals, emergency generator, legally required standby generators. If the generator is not working, I need to know about it. So if the generator is sitting here, we have an annunciating panel right outside, and if the battery goes dead, it will have audible and visual. Sound start beeping and light starts blinking, saying, oh, and you go there and you look and you say, oh, battery's dead. Very, very important. Why? Emergency system, you would hope it's ready for you to run, right? If I have an emergency, I want it to be warm, hot, ready to run. So they have something called derangement signals. Audible as well as visual. So audible as visual, as well as visual alarm. Installed outside the generator room. You have to put it outside the generator room. Indicate malfunction. Why do we need that, baby? Malfunction generator, load on the system, correct operation of the batteries. So if you have a ground fault, it will indicate you have a ground fault. If you have low fuel, if you have battery dead, if the charger is dead, if your exhaust is blocked, if so many things on that little annunciator panel that comes with the generator that can announce anything that's going to compromise the running of this generator must be announced. Does that make sense? So when you design a generator, you put the gen here, and remember, you're going to have outside that little so-called derangement signals that can give you indication of what's going on. Actually, the signal, the visual alarm signal can be outdoor, but the panel that tells you what the signal is could be inside. So I can see a blinking light and a horn going on in front of the room that has a generator. I walk in and look at the annunciating panel. It says, oh, by the way, the battery is dead. Is that good for an emergency system? That's part of the survivability of your emergency system. Okay, with emergency system, we always, guys, have transfer switches. Position of the transfer switch, side of the overcome protection device, type of, you have to have an emergency with emergency system, legally required standby system. I would say 70% of the time, you're going to have some type of an auto transfer switch. So this auto transfer switch can be auto or can be manual. I guarantee you, the only time you can have it manual is if it's optional standby system. Everything else has to be auto. Legally required, critical operation, as well as emergency has to be open, manual or auto. Auto transfer switches. The auto transfer switch, guys, remember when Jay was here, the job of the auto is to sense that the power is lost first, and then close the contact to start the generator. And when the generator comes up to speed and energize this side, it flips the whole building or part of the load to this side. Really, that's the job of the emergency system. Start the engine, transfer. A lot of people forget that little function here. Start engine of emergency generator or any generator. You have to be able to sense the power lost with the battery and shoot yourself a signal, close a contact to start the generator through the batteries, has batteries in the generator. And then, of course, transfer the system. Okay, so with the transfer circuitry, guys, the transfer switch circuit, these are, if it's emergency transfer switch, everything related to the transfer switch is emergency. So the control circuit have to be separated in a different conduit and the power circuit and so forth. Any question, guys, about the transfer switch that comes with emergency legally required standby system? The job of your auto transfer switch to shoot you, to start your generator and transfer you to the other side. We talked about branch circuit must be separated from standby system, except for special conditions. The special conditions is that little bug eyes, because it's coming from there. Here's what, right here. This is where really nice picture. You're coming with an emergency system right here, guys, and you need to switch it. Can you guess if you see there's a barrier here? They're in the same box, but there's a barrier between them. And I have my emergency circuit coming from here, going to this fixture right in here. Can you see that? It's coming to this fixture. So this circuit is actually coming from, there's a gen here, and there's utility, and it's somehow auto transfer switch and feeding this circuit. Can you guys see how it's separate? What's the difference? Can I put these two circuits in the same conduit? No. Very clear. In the same box? No, unless you have a divider. They have a box that can slide a divider between them. You're good to go. Yes, sir. There are two methods of doing it. One dedicated switch, or two dedicated switches. This one is two dedicated. This is, by the way, keyed switch. You key it on and you leave it on in this situation. In 2011, there's another way, guys, where this fixture here, this fixture, inside the fixture itself, you will have a relay. Inside the fixture, you will have a relay. In the relay, you're going to have, inside the fixture, you're going to have a relay. On the relay, you're going to have a circuit coming from the normal and a circuit coming from the emergency. Okay? Circuit coming from the normal, circuit coming from the emergency. Inside the relay. So the relay will sense if the circuit coming from the normal, it will switch you to the emergency. And you still can control this circuit. This light can be controlled like a normal light. I can turn it on and off because it has a switch. The emergency has no switch. It's not switched at all, the emergency, but just sits there. If I lose the power right in here from the emergency, this relay will, like a transfer switch, flip me into the emergency circuit and will energize it. Energize the fixture from the emergency circuit. That's one way. Or you have to key it on though. You do it this way, you key it on. Lock it. You don't want to be able to, because if you turn this emergency fixture off, there's no way on earth you can turn it on again. Auto, yes sir.
So do lighting transfers make like a balance like certificates emergency that has that relay?
You have to buy the relay separate. Yep. The relay, you have to buy the relay separate. I have a wiring diagram that we go through the code update 2011. It became kind of official in 2011. Really nice diagram. I can show you for you. Shows the whole wiring put together. Okay, so that's your emergency system. Wiring for normal emergency circuits. Bring it to the circuit. A couple of things. Sizing generator. The last thing, guys, it talks about sizing generator with UPS. UPS, it used to be the rule is if you have a nonlinear load, it used to be the rule is if you have a nonlinear load like UPS, nonlinear load, you double the size of, so if the whole load is say 200 kVA, when you size your generator, you times it by 2, that becomes 400 kVA, and you size your generator for running. Harmonic loads are very bad for generators. With the softwares that we have, guys, your software will take this into consideration. The nice thing, when you see, when you did VFDs, remember the VFDs, guys, or UPS, it will take into consideration to double the load, to allow the generator to pick up a UPS ugly, dirty load that the UPS is going to create in your system. and VFD. So keep in mind, I don't worry too much about these because we have the software, guys. You plug them in. Every time you have a UPS or VFD or soft start, the software will actually add more loads just to be able to handle more size to the generator to be able to handle these ugly situations. Okay, so that's, I'm going to show you a couple of pictures here and then I'll let you, we talked about this one. Okay, let me see if there's a couple of things. We talked about this one. Okay, here's, if you have an emergency generator, guys, here's one way of doing it. These are all in your book. This is service disconnect with transfer equipment connected downstream. If you have, one way of putting your transfer switch is you put your main panel here, and downstream, you feed, this will be your emergency panel, right? And I'm only feeding the emergency panel. You can do that, no problem. That's only picking up the emergency panel. Make sense? So you have your main panel, one feeder, and from the main panel, there's multiple feeders. So if I need another panel from here, and a third panel from here, and a fourth panel from here, here's my mechanical panel, here's my receptacle panel, here's my lighting panel, and down here is my emergency panel. Does that make sense? Way down as a feeder. That's one way of doing business. Cheaper. You can buy a cheaper auto transfer switch for this system. If you go the next way, if you do it the other way, look at this. If you do it this way, can you see how like we did it? Isn't that what we did, guys? We did it. Then this will be your main panel. Your main panel will be here, my main panel. This one has to be, first I have to have an off position because it's a disconnect now. And it has to be rated for service entrance. It has to be service entrance rated. So you have to have an off position because it's a disconnect for the whole building. Not a big deal, they make them. Who cares? If when you buy an auto transfer switch, they ask you one question: do you want it to be service entrance rated? If you are putting it ahead of the building, the first thing, if the service is coming to it, say yes. If you're putting downstream, say no. Who cares? It's bendy. It costs you probably 50%, well, 30% more to have this put here than putting it downstream. So you have to be able to bond the neutral to the ground. It has to be resilient. You have to have an off position and so forth. Any question, guys, about this? Another scenario, which is a little bit more expensive but better too, is to have an enclosure. That's what commonly used, guys. You have you have an enclosure right in here, and you have your main disconnect switch here, or and you come into the service. You bond the neutral to the ground. Here's my neutral. Here's my ground. Bond it together here. Bring it to Mother Earth, and then out you transfer to the generator, and then you bring it down to the panel, main panel. Then the whole system has to be the whole box, all in one box with different sections. This section here has to be rated for, obviously, service entrance equipment. Make sense? What's the difference? See how the main is here versus the main one's down here. This does not need to have off position. Almost all of them do. Off position because that guy is the disconnect. So please look at these guys, especially with generators. Very nice pictures, illustration of how to do your generator. Okay, moving on. We talked about this one. A couple of bug eyes, generators. This is the sign, guys. The annunciating panel that tells you low voltage. You have low voltage in the batteries. The batteries is dead. The charger is dead. All this good stuff. Couple of relays and disconnect and switches. Okay, this is my favorite. This is really nice. Please, if you guys look at this one, this is really nice comparing between the three systems that we have. This is nice comparing the three systems that we have together. I want to bring to your attention, guys, the following. Here's my emergency system, legally required, standby. Look at this. Rules apply only for legally required. Yes, yes, yes. Equipment approval required. Yes, yes. these are yes, no, but maybe the authority having jurisdiction, no, but maybe the authority having jurisdiction. Restoration of power, 10 seconds, 60 seconds, whenever. Can you see that? Transfer switch, yes, listed. Arrow, yes, listed, and suitable for the intended use. So it doesn't have to be listed. Priority for load, this is the highest priority, second and least, or lowest. Make sense? This is one of the best slides that compare the three systems together. Permitted to supply other systems, emergency, standby, no. Circuit conductor isolation, this is the most important thing. Yep, isolation. Connection mode of ahead of a normal service disconnect means this is no. This is yes, with approval from the utility. Separate service permitted, this is the question mark here. This is a yes. This is no here. Yeah, you can, for standby system, separate service permitted, yeah, if it's standby system. Selective coordination. This is important for you guys, especially if you're working in engineering firm. Do I need to have an overcomputation coordination, like I'm going to show you later on? Yes. For these two systems, yes. Installation and periodic testing, you have to test both of them. The other one, this is guys the least important. You can see not a whole lot of requirement to it. Signals and signs, yes, yes. Ground fault protection, protection of equipment required, not required. Permitted here, not required. Ground fault indication, yes. Can you change this no into yes? In 2011, guys, they changed this one into yes too. In 2011 change, both of them need a ground fault indicator. So if you have a ground fault in legally required or emergency system, you need to be able to do it. On this one, no permitted, this is yes. And so this is really the best slide that compared the three systems together in terms of requirement. Any comments, any questions, guys? That's what I wanted to shoot you to look at. Locked rotor current, we talked about locked rotor current. One little example I'm going to say for locked rotor current. Suppose I have a B motor and I'm going to use this multiplier. So here's what we do, guys. With 0.54 multiplies by, suppose I have a 50 horsepower. Here's a 50 horsepower. And that will be my kVA. That will be my kVA. That's it. Why kVA? Because this is in kVA. So if you want to find the kVA start for any motor, find the locked rotor current for the motor, say this number, multiply it by the horsepower of the motor. Done. That's it. That will give you the answer will be in kVA. kVA. Nice softwares that we have, guys, always take care of them for us. The softwares always take care of them. This is for smaller motors. This is interesting too. Requirement for this is requirement for transfer switches and equipment. Look at this. In emergency, in the hospital, do I need an auto transfer switch? You would hope so. Does it have to be listed? Emergency system, yes. Emergency system, auto, yes. Emergency system, there's a white book that talks about emergency system, guys, IEEE. Legally required, it has to be auto. Legally required standby systems. Have another white book talks about it. Optional. Auto, yep, or manual, no problem. Suitable for the intended use, doesn't have to be listed for emergency. Critical operation, yes, auto. And the same thing, the white book talks about it. So these are kind of which one need auto. Again, the only one that does not need auto is what? Optional. It's called optional, right? So that's a few things about generators. Okay, that's about it. Any comments, any questions about this article? If you work in an engineering firm or electrical contractor, guys, this topic is very important. We're going to visit this topic one more time, William, my friend, in the spring. 5 minutes break, and we'll talk about overcomputation device.
Can you look at the formula on page 370 and tell me if there should be an equal sign right above table 16?
Yeah, give me 1 second here. I'll be with you.